All right, welcome back. I hope you're having an amazing time so far. Our next speaker is Fabrice Guillaume. He is a Senior Director of Machine Learning Engineering at Capital One. Please join me in welcoming him to our virtual stage.
Patricia, thank you very much, and welcome everyone to this session. We will be talking about machine learning as a service. And with that said, I will share my screen. Wonderful. So we will be talking in this session around machine learning as a service. That is a platform that I am currently responsible for at Capital One. And in a nutshell, it's really about offering to our data science community the reuse at scale of machine learning algorithms. So maybe let's start with a quick intro about me before we talk about Capital One and machine learning as a service. I've been at Capital One for close to 4 years now. I come from a big data wireless background. I have a master's degree there. And I've been building tools and platforms first in the wireless industry before lately doing it in the financial industry at Capital One. And outside of work, I'm passionate about outdoor activities and love being in the mountains with friends and my kids. And so talking about Capital One, where I've been at for close to 4 years, maybe a quick overview of the company. I would really say this is really the bank, right, that a great technology company would have built. We're passionate about not just powering up great user experience, but really leveraging the power of the cloud, of machine learning, of real-time data to power up some great user experience for our customers. Rich Fairbanks, our CEO, has had a great vision that we're executing against. And with the help of great data scientists, product managers, technology team, we're basically all in the cloud using agile methodology, RESTful APIs, microservices, containerization, and really currently focusing a great deal on building platforms. And MLaaS that we'll be talking about in a few minutes is one of these platforms. So let's actually talk about MLaaS. What are the problems we are trying to solve with MLaaS? Let's start with a very simple problem statement. At Capital One, like I'm sure in many large companies, technology team, data science team, product teams are really nimble, right? Each of them is empowered to make local decisions and bring to market some great capabilities. These local decision-making and these distributed teams are amazing, right, to ship great software and capabilities very fast. However, it also creates very often some code duplication, and teams very often operate in silo. And that's actually what MLaaS is trying to solve. We are trying to enable the reuse of algorithms along with infrastructure so that these different distributed teams can reuse the same algorithms and infrastructure behind the scene. And on that slide, you can see on the left, a typical example. In that case, it's doing community detection or clustering on graph data, where two separate teams use the exact same algorithm, right, on their respective data sets. On the right is where MLaaS now enabled that same algorithm called Louvain to be wrapped and actually offer as a API so that the exact same two teams can actually now reuse that algorithm along with infrastructure behind the scene. And as they do that, we can then onboard additional use cases and teams to also use the same algorithm. And if I was to really explain MLaaS as a platform, what are the 6 key pillars of MLaaS? One of them is really offering a marketplace. A marketplace being the place where our data science community can go and discover different algorithms. We're currently offering algorithms such as natural language processing and understanding, time series and anomaly detection, model validation, and graph machine learning. As the community go to that marketplace to discover these algorithms, they can then use our Python SDK and a REST API to start onboarding that algorithm on their data sets and solve their problem, their use cases. Behind the scene, through that REST API and Python SDK, they can orchestrate these algorithms and start sequencing them, scheduling them to work in parallel, in sequence, and essentially start building a really creative pipeline or workflow to start solving their business use cases. Again, assembling these algorithms together. For that exact same community, we're also offering them a dev tool, CLI, or command line interface, which allow them to self-onboard new algorithms that may not be available yet in the marketplace. And so with that, we're empowering the community to essentially drive the marketplace list of algorithms and self-onboard additional capabilities, which is why one of our key pillars is community-driven. And that's really an important part here of building a platform at Capital One, right? We're not only just using open source libraries and framework outside, we're also very much via inner sourcing internally, contributing back to them and offering our community the tools to add more capabilities. Lastly, our platform is nicely integrated in a cohesive ML ecosystem. We're very much into building platform at Capital One. And so we have sister teams that we work very closely to start enabling platforms through the entire ML lifecycle, from feature engineering with a feature platform to machine learning, build, experimentation, and serving with our machine learning platform, to monitoring these models at scale and production with our monitoring platform. So who is our target audience? Our target audience is primarily data scientists, data analysts, machine learning engineers, and software engineers. And with machine learning as a service, we're giving them two paradigms. On the right is the consumer paradigm, where they can use and apply an algorithm on their data set and solve their problem and their use cases, leveraging via, again, the REST API or Python SDK, that algorithm and infrastructure that scales behind the scene. On the left, that community can also add and contribute new algorithms to machine learning as a service. And typically that will be algorithms that they feel have been built in-house at Capital One, or open source algorithms that have been extended and tuned for Capital One needs that can generalize to other use cases. So let's see these algorithms and use cases. First, I will present you the pillars of the marketplace of machine learning as a service. You can see different focus areas, from detection as a service on the left, where we can do anomaly detection and change point detection on univariate time series. You will see another pillar of algorithms that actually is helping with root cause analysis and diagnostics as a service. And you can see basically here an example of a two target, one sample analysis, comparing two model outputs and trying to understand what is causing the difference from data drift or model performance. We're offering a library of NLP processors to do natural language processing and natural language understanding, from part of speech tagging to text preprocessing, generating word embeddings, doing name entity recognition, and more. You can also see GraphML as a service. That was the very first example I presented, with Louvain being one of the algorithms performing community detection. And last but not least, working in a highly regulated industry, we also need to make sure we're well managed when it comes to model governance. And so we're offering to our model risk office team in particular, the ability to streamline their existing processes. And one of them is to, for example, review white papers, right? Leveraging, in that case, natural language processing and a classifier downstream. So these are a few examples of algorithms that are currently enabled on production in MLaaS as part of our marketplace. To see it in action, you can see here an example of time series, where on the left we do anomaly detection, in the middle we're doing change point detection, and we're actually pairing both algorithms with a third one downstream to do root cause analysis. And the really nice thing here is, for a data scientist typically, they could very quickly not only experiment here, but progress this workflow of 3 algorithms to production very quickly. And then run it at scale on over 100,000 of univariate time series, 24/7, right? So there's really a cool aspect here of accelerating machine learning and scaling it, right, for our data science community. The next slide is really to tell you more about how it's built. And so without going too much in detail, let's talk first about the tech stack. Like any platform, we're following some software best practices. One of them is the microservice architecture, containerizing our microservices, and running it at scale in the cloud. We happen to use AWS as our vendor for running in the cloud. Our microservices are hosted at scale in the cloud, as I said, and we're fronting them with a set of APIs. And like any experiment, we first starting simple, serverless Lambda-based type of architecture, and gradually we gradually matured it, to start scaling to many more use cases, many more teams, and handling much larger data sets, to now using an ECS compute and using a Kubernetes compute. And typical use case would be, as you would think, very batch-centric for training a model, to some of them being near real time. And for each use cases, we're actually using different data stores, right, where the features are persisted. It could be file-based, type of this system access, like S3, HDFS, to maybe be more in memory or be more streaming with a Kafka type of access, or typical Snowflake or other SQL relational database. Behind the scenes, we have a pipeline that takes care of doing pretty much the whole heavy lifting of shipping these artifacts, running them at scale, and we're using obviously monitoring tools to monitor the health of our platform. That slide is really about also showing a cohesive ML ecosystem. As I shared earlier, machine learning as a service is not just a standalone application, it's really a service layer that's actually embedded in our entire ML ecosystem. And so you can see different layers in that slide that start from low-level compute, data access, to enabling workflow orchestration, to enabling tools and framework on top, to then enabling libraries as a service. And ultimately adding then more and more degrees of customization as we get closer to the business team and the business use case. So what is the consumer experience? I will share in the next few slides, basically how would a data scientist use machine learning as a service. In this case, we look at leveraging the Python SDK, which abstract for our data science community the REST API, which is fronting MLaaS. And really the steps are extremely simple. It's a 3-step approach. You first connect your data source. You then run the machine learning as a service algorithm against the data source, which is essentially fitting your algorithm on your features. And then you sync your result. Behind the scene, our Python SDK actually interacts with our REST API. And you can see here our REST interface is extremely simple. For a supervised machine learning algorithm, we enable our data science team to first fit or train their algorithm on the data set, and then use the model object to start predicting on unseen data or real data or production data. For unsupervised machine learning algorithms, you would just run a single REST call called execute. Louvain that we just talked about earlier would actually fit that paradigm. The other REST interface endpoints are more for tracking status of the jobs running. Some of them could actually take a long time, especially for very large data sets. Now let's look at the Python SDK use in action. I will show the next 3 slides with a Jupyter notebook experience, which I am sure many data scientists are very comfortable using and probably use daily. What you do is, after keep installing the MLaaS package, you import it, and then you essentially instantiate an MLaaS client. How do you do that? You just pass it your client ID and client secret and specify an environment. In that case, we're instantiating an MLaaS client in this Jupyter notebook to access our production environment. The second step is very simple. you tell machine learning as a service, where is your data? In this case, it's actually stored in S3, right? That's not the only source that we interact with, but for that example, we'll use S3. In that S3 bucket, we actually have a JSON test data file that's actually available. So we're basically presenting that file to the algorithm. How? Well, very simply by actually passing it as a source parameter to the execute method here. So the source is set to S3. The destination is where you want the output of the algorithm to land. In this case, we also use S3, right? We provide it a file name, which is also going to be a JSON file name. And we pass it also as another parameter here. And the only thing missing for the execute method to run is the algorithm itself. We actually specify that as part of this client.model call. In this case, we use MLaaS, that is a Python package built at Capital One to perform time series and change point detection on time series. We're also specifying here the version 0.5.0. We track versions and upgrades of our packages over time, obviously. And that's it. You can look at the signature of that code. Is very simple. We instantiate MLaaS and we run .execute method by saying, pull the data from the source, run obviously yourself MLaaS. In this case, we also pass a parameter, which is about running exponential moving average, which basically takes the average and decay all the count exponentially. And we say sync the data to the destination. And that's it. Just run it. This will, behind the scene, pull the MLaaS package from Artifactory, run it as part of a container into our infrastructure at scale against S3. And once it's done, proceeds to the destination. Once that is done, your data will land into the destination bucket and you're done. This is the end of MLaaS. Now, you as a data scientist can do the downstream steps. In that case, for example, looking at the data here on the left, we're loading the result file into a standard data frame, and we actually found 2 anomalies in that time series. While this may not be trivial to read, we can use some matplotlib to actually visualize the 2 anomalies. And so you can see here on red, the 2 changes, right, in slope. This last stage, again, is outside of MLaaS, but I just put it out there to give you a feel for how a typical data scientist would use it. And that's about machine learning as a service, really in a nutshell, at least for the consumer experience. With that said, I'm going to add a shameless plug. At Capital One, we're looking to really build a top-notch technical and data science team along with product partners. And so we're actively hiring. So if you are interested, please ping us. You can go on the Capital One career website. You're welcome to also reach out to me in LinkedIn. And thank you.
Amazing, Fabrice. Thank you so much for sharing with us. That was incredible. And I know this virtual audience is giving you a huge virtual round of applause. Thank you again for sharing these insights with us today. For the audience, it's time for you to make your way to your next session. Along the way, make sure you accept your connection request and take some time to check out our amazing exhibits. Thanks so much, and we'll see you around.